Hello again. So you haven't seen me for a while, so hello. This part of the evening is the more entertaining. No, I'm kidding. It's still just code. I want to talk about a little bit more about the more practical parts. So the first one was about like theory, how this all works, and in this case we'll see how you can sort of drive it from Python. We'll do a sort of brief run through of what we can do, but then because I don't imagine that everybody would be interested after this, I'll just sit somewhere, and whoever's interested in more thorough demo will be more than welcome to see me. If not, if no one, I won't hold it against you. I'll just have another beer. So, Python DSL it's a Elasticsearch DSL in Python. If you're already coming from that, is a library that I wrote for Elasticsearch, which provides a domain-specific language for Elasticsearch. Because what you can do, and if you want to use native Elasticsearch, if you want to write a sort of an average-sized query, this is what you end up with. Don't worry, I don't expect you to be able to read this, but this is how you write queries. You just write these complicated JSON objects or dictionaries in Python, and you have to know everything. You need to know how you combine two different queries to match them together. How do you add aggregations? And first and foremost, you must be very comfortable with writing quotes and curly braces, because you won't be doing much else. So surely there must be a better way, and the better way is what I actually tried to make happen. So imagine that you had something like this, and you wanted to add a filter to it. Sure, it's not that complicated. You just need to verify that the query inside this is already a filter query, which means that it has a filter. Then you need to verify whether that filter is already a bool filter. In that case, add it to the bus branch of the bool filter. Otherwise, convert it into a bool filter, add this filter to the bool filter, and add the new filter to the bool filter as well. Easy, right? Well, it is easy. There is no significant thought process involved, but there is a lot of drudgery involved. So I try to take that away from it, so that people who face this problem very often, which is honestly a very reasonable problem to have, and it is very common, so that these people don't have to think about that a lot. So let's start from the beginning. If we wanted to reconstruct that horrendous query, that's actually not the most complicated queries that you can run. It's about average. So how would you do it with a DSL? So first you start with a search object. You limit the search object to a certain document type. So in this example, I'm looking for documents on Stack Overflow, because the people at Stack Overflow are very nice. They actually publish all their data is Creative Commons. So I actually base most of my demos on their data. So I'm looking for questions on Stack Overflow. And I'm looking for questions that mention PHP in either title or body. So I'm using the multi-match query over the fields title and body. I say that title is more important to me than the body. And I'm looking for the term PHP. So far, so good. Then I add another query, because Elasticsearch is capable of capturing some relationships between documents. The first one of those relationships is a relationship between a parent and a child, so one-to-many relationship. In our case, we've used that to capture the relationship between a question on Stack Overflow and a set of answers. So now we're using that, and we're asking for a question that has a child of type answer, whose body matches Python. So essentially, someone asked for a question about PHP, and the answer mentions Python. So far, so good. So you notice that we're using the queue object to represent sort of the query. I lifted that one from Django a little bit, and because I have several different ways how to actually represent a query, a core query. Either you can just use the dictionary. If you're not afraid to type a lot of curly braces and a lot of quotes, go for it. I won't stop. Or you could just grab the absolute same thing in a queue object, and that way you actually get back a query object, which you can do several things with it. Or, which is the preferred syntax, is you essentially deconstruct. You can see that the typing is fairly similar, except for the more complicated involved characters. So you still have to say what type of query it is. So it's a has-child query. But then instead of just having everything as dictionaries, you use keyword arguments, because Python has those, to capture the rest. So here you have child type answer, query, and then another query, which is exactly the same. So this is by far the preferred solution. If you will ever feel that you absolutely need to be in control, you can actually import the classes for hasChild and match queries and use that directly. That's entirely up to your level of OCD and laziness, and how do you balance those two. Once you have the query object, there are several things that you can do with it. And so there are some operations that are supported that actually captures the logic, how queries are combined or altered. You can end two queries together, so that you don't have to remember that in Elasticsearch, when you want to add two queries together, it's the same as having a bool query with these two queries in its must branch. The same if you want to OR them together, it's a bool query it should, and if you want to negate a query, then just use the must not. And this is the stuff that you don't have to remember and memorize, because you can just use the operands as you know them from Python itself.
But you could use the right type.
Of course. Again, OCD, laziness, depends where you're on the scale. I lean way more heavily towards the laziness. So let's move on in our building of the query. So we also want to add a filter. So now a word of warning, the difference between filters and queries. We've talked about queries and how they will allow you to match certain things that are close, that are similar, and they produce a score, how well a match is. Filters are a little bit different. Filters are binary, either it matches or it doesn't. The concept of relevancy doesn't come into it. So filters are perfect for things like ranges, exact matches, and general stuff like that. It's the things that you're used to from other data stores like SQL. And the best part about filters is they're super fast and they're actually cacheable. If you use always 5 filters, so you want to always say, this one, I am looking for an article that is published, has been published in the last month, has been published by this author, etc. And you keep reusing at least 4 of them. So let's say that 4 remain the same and 1 changes. We cache the filters on the lowest possible level. So we cache the individual filters, and then we can combine them effectively. That means that even when you run 2 different queries that only share some of their filters, at least for the filters that are shared, the cache will be reused. So it's not the case that you change one simple condition and suddenly the cache is not usable anymore. That's not the case with filters in Elasticsearch. Also, by me saying cache, it doesn't mean that you'll ever get stale data. It's just an internal mechanism. Okay, so we've added a filter to the query. What else can we do? We can also exclude some queries. So in this case, remember, we're looking for a question that mentions PHP, which has been answered by something mentioning Python. And now we are saying that we don't want, there's a negation there, we don't want the question to mention Python, sorry. So essentially, we're looking for someone asking for a problem of PHP, not mentioning Python at all, and some helpful person answering with, hey, just use Python. So we're essentially looking for trolls on Stack Overflow. Not a hard job by any stretch of the imagination. So we can exclude stuff. If your level of OCD is high, you can just actually assign the query yourself. You don't have to rely on the library to compose the query for you. You can manually assign it. In this case, I'm using the mechanism to wrap it in a function score query. So I'm taking the query and I'm wrapping it in the function score query, where I'm essentially telling Elasticsearch, hey, I know that you can tell me which questions match the best, but I also have this one information. I have a field called rating on my documents that has been actually put in by users. And we still live in a world where the assumption is valid that people know better than computers. So this is telling Elasticsearch, use the value in that field and combine it with a score. So if you have a good question, something that has been rated as good on Stack Overflow, take that into account when calculating the score and when, in the end, sorting the results. What we can also add is adding aggregations, because Elasticsearch can not only locate the relevant documents for you, but it can take all the documents that match the query and run certain aggregations. When we think about aggregations in general, it's essentially taking data that you have and dividing them into buckets. In SQL, those buckets are created by the group by statement. So you say group by tag, which will essentially create one bucket for each value of the field tag. So this is us doing the same thing. We're using the terms aggregation over the field tags to create a bucket per value of the tag. Inside each of those buckets, we're asking for a metric. The metric will be called comment average in the results, and it is an average calculation over the field comment count. So we have a numeric field in our data called comment count, and we're asking what is the average value of this field per each bucket. And then we add another aggregation, which is asking for a frequency, which is essentially a date histogram over the field creation date per month. So we're creating in one bucket for each month. And we're asking for how many questions were asked during that month. And the final things we're adding is we're looking for highlights. So we want actually to be able to present snippets, the relevant snippets of the question that match the query, of both title and body, to the user. And that's it. By now, we've actually reconstructed the entire horrible JSON that we started with. So by the incremental steps, and that's what the library does for you. Instead of having to memorize how do you actually construct this horrendous JSON, and moreover, how do you modify it, you can just construct it step at a time, and everything will work for you. So this is not important for us. The other important part for us is if you actually then execute the search, you don't get back just the raw data, just the dictionary that just the JSON that Elasticsearch sends back, but it's wrapped in some sort of convenience wrapper so that you can actually access the fields just using the attribute notation. So you don't have to say it's square brackets, quotes, title, and end quote, and square brackets, but you can just use attributes. The same goes obviously for the results of the aggregations. So that's sort of on the part of the queries. Now for sort of the persistence model. If you want to use Elasticsearch, how do you put the data in there and how you define what data you have inside Elasticsearch. Again, this part is not really relevant, not really interesting. This is the interesting part. As part of the library, you have a doc type, which is a class very similar to Django models, which allows you to define the schema in Elasticsearch. Now, many people say that Elasticsearch is schemaless, that you can actually index anything. And that is only partly true. Elasticsearch is not schemaless. It is a dynamic schema. So, you don't have to supply the schema, and you can just start indexing data, but it has a schema. So once a field is set as being an integer, it has to be an integer, and it will actually be enforced. So if you index one document when the answer is 42, because the answer is always 42, and then you try to index another another document where the answer is a text, it will actually fail. Because by the time Elasticsearch has created a schema for that field saying, hey, this should be an integer. So that's the difference between a schemaless and dynamic schema. So typically you want to specify your own mappings. That's what we call schema. So this is an example. We have three fields here. We have a string called date. We have a string called title. We have a date called created date, and then we have a nested document, which is a second type of sort of document relationship that you can capture in Elasticsearch. We talked a little bit about parent-child, which is like the one-to-many relationship. Nested is a little similar, but used for a different use case. This one is used where the smaller documents, the children, are part of the bigger documents. In our case, you use it for the comments on a question. So instead of overflow, you have a question with comments, and then you have the answers, and each with its own set of comments. So nested, if you specify that the comments are nested, it means it will be indexed as part of the parent document, as part of the article in this case. But they can be, in some cases, referred to as individual documents. And then I have some map information, some essentially configuration, not very exciting. I can obviously define my own methods. I can override the save method that is there if I want to do some denormalization or something like that. And this is how I actually create the schema in Elasticsearch. This is how I create a search. And this is another approach. This is an approach that's useful if I want to specify multiple. For example, I can say search doc type, article, comma, question, comma, something. And it will work. So that's pretty much it. I don't think we need anything else, because that's fairly Elasticsearch specific, and I don't want to bore you too much. I'm okay with boring you this far, but the line should be drawn here and no further.
Enough.
Yes. So
Don't boring us.
So if you have any questions, now's the time, and otherwise I'll sit somewhere in the corner and do the demo for some people who would be more interested. So questions? Honza. Thank you very much.